Hey, eighth graders, I hope everyone is doing well. This week, January 11th through the 15th, we're talking about functions. So hopefully by now you have already taken the pre-test for this unit. If you haven't, please go ahead and stop the video and go take the pre-test first, just so I can see what you know right now about functions, and then come back to the video. So let me share my screen with you and we'll talk about functions. Well, first, let me just give you an example. So let's say when you flip a light switch in your bedroom, what do you expect to happen? You expect the light to come on, right? Well, every time you flip the light switch, the light comes on. What if one time you flip the light switch and the water in the bathroom turned on? Or what if you flipped your light switch and the oven in the kitchen turned on? You would say that that light switch is not functional, correct? Something's wrong with it. So that's kind of an example. That is an example of a function. So if for every input, so flipping the light switch, there should be only one output. One thing should happen. For every input value, there is a unique output value. So that's basically what this says. It's a function that relates two quantities so that each input value corresponds to exactly one output value. The domain, so we're going to talk about domain and range. So domain is all of the input values. So if you're looking at a T-chart and XY chart, the domain are all of the X values, the input values, and the range would be all of the Y values or the output values. Functions can be represented in many ways, including tables, graphs, and equations. If the domain of a function has infinitely many values, it is impossible to represent them all in a table, but a table can be used to show some of the values. All right, so on your first quiz that you'll have, it asks for the function definition basically, and so this is what we're looking for. An output, or the Y value in an XY table, an output is the result of a relation or a function rule, usually the Y values, in a set of ordered, I think that's supposed to say ordered pairs or ordered points, in a set of ordered pairs or, oh, I messed up that definition, didn't I? In a set of ordered pairs or on a table or graph. I'll fix that before I send this to you. An output is the result of a relation or a function rule, usually the Y values, in a set of ordered pairs or on a table or graph. So that's that first little quiz you'll have. I think that's question number 1, actually. All right, so let's look at the first example. So here we have an equation, y equals 3 minus x squared. So they've given us some values for x. And then what we need to do is plug in, my thing's not acting right here. All right, so you're gonna plug in each of these x values into the equation right here. So we're going to say, what is 3 minus negative 2 squared? Ignore that line, my pen acts crazy sometimes. So negative 2 squared is 4, negative 2 times negative 2 is 4, and 3 minus 4 is negative 1. All right, what if x were negative 1? It'd be 3 minus negative 1 squared. Well, negative 1 squared is 1, and 3 minus 1 is 2. All right, what if x is 0? 3 minus 0 squared. 0 squared is 0, so 3 minus 0 is 3. What if x is positive 1? 3 minus 1 squared. 1 squared is 1. 3 minus 1 is 2. And then 3 minus 2 squared. Well, 2 squared is 4, and 3 minus 4 is negative 1. So those are ordered pairs. So ignore the middle column. So our ordered pairs will be negative 2, negative 1, negative 1, 2, 0, 3, 1, 2, and then 2, negative 1. So if we graph those points, oh, does it give us all those answers? It gives us the same answers. All right, so if we graph those points, we get that it's actually called a parabola. So does every X value have one unique Y value? -2 goes with only -1, that's right. -1 goes with +2. The X value of 0 goes with a number. The X value of 1 goes with a number, and the X value of 2 goes with a number. So that is a function, because basically what you're looking for is that there are no repeating X values that have. So for example, let's say down here, this isn't, let's say if they added -2 again and said when X is -2, Y is 5. Well, then we would say, well, what about this? When X is -2 here, Y is -1. So basically what you're looking for is to make sure that the X values do not repeat. Okay, if the X values don't repeat, it is a function. It's not important if the Y values repeat. That doesn't matter. If the X values do not repeat, it is a function. All right, so then it gives us the same kind of scenario. We're given this equation, Y equals X plus 1. So we're going to put our X values into the equation. So when X is -1, -1 plus 1 is 0. So I assume they're doing this for us again. Yes. So -1 plus 1 is 0. If X is 0, 0 plus 1 is 1. And then we graph that. This is -1, 0. This point right here is 0, 1. What if X is +1? 1 plus 1 is 2. And then 2 plus 1 is 3. So that is a function. Do any of the X values repeat? Nope, there's exactly one Y value for every individual X value. So that is a function. So let's look at this table, XY table. We have 1, 2, 3, 4, 5, 6. Every Y value goes with a specific X value. So this is a function. Now these are a set of ordered pairs. So we could turn these ordered pairs into a T-chart if we wanted to. So our first ordered pair is 1, -2. The second one is 3, -5, 5, 2, and then 7, 5. So this graph and this is called a relation. This set of ordered pairs in my graph match. And do any of the X values repeat? Nope. So it is a function. But let's look at letter B. When they say that X goes with 2, the X value of 4 goes with 2, but then they also tell us that the X value of 4 goes with -2. So since it's telling us that the X value creates 2 different Y values, this is not a function. That is not a function. So that's how you tell from a table or a set of ordered pairs if you have a function. Is there one Y value for every X value? There should be. Now these are called mapping. These are you could turn this into a T-chart, kind of, you know, the way it's written. You could say, okay, well, these are the input values. These are the output values. Does every X value go with exactly one Y value? Yep, so this is a function. This is also a function. So even though it looks crazy, it's fine. This, if we wrote this as an order pair, this would be -1, 3. And this would be 7, 3. Like I said, the Y values doesn't matter if they repeat, but since all of our X values only point to one unique Y value, this is also a function. Both of these are functions. However, look at this one. This is saying that the input value of 3 goes with -4 and +2. So since they're saying that the 3 goes with 2 different Y values, this is not a function. And this one is not a function. Why? Why is this one not a function? Because of this right here. So 4 goes with 5, but also it goes with -5, which is not right. Or it's not right, it's just not a function. So if a relationship is a function, each input has exactly one output. When the relationship is graphed, we can use what we call a vertical line test. So we're going to take the picture, we're going to place a vertical line through our picture. If our vertical line intersects our graph At only one point, the relationship is a function. If it goes through the picture more than one time, it's not a function. For example, the blue squiggly thing is the function, or the picture, that's what's been graphed. So we took a vertical line and we went through the graph and we're like, uh-oh, on the same vertical line, it went through our picture twice, which means this is not a function. So anywhere on your picture, if you can draw a vertical line at any place and it goes through your picture more than one time, it is not a function. All right, what about this? So if I made a vertical line here, it only goes to my picture once. If I make a vertical line here, it only goes to my picture once. If I make a vertical line here, it only goes to my picture once. So no matter where I draw a vertical line, it only goes to my picture once. So this represents a function. It is a function, okay? And we are using the vertical line test to determine that. So what would be an example of a non-function? So let's say I have a graph and I have this kind of line right here. This crazy pen, it drives me crazy. Is that a function? It's not, because I could do a vertical line and say, oh, it goes to my picture more than once. Or let's say I have another graph. Now if my line bends up, that is a function. It would pass the vertical line test. This one, nope, not a function. This one, yes, it is a function. All right, it says determine if the relationship represents a function. Well, every x value has exactly one y value, so it is a function, right? What about this? Linear equation. Well, if we did a vertical line test anywhere on my graph, it would only go through that line once. So it is a function. All right, if you have an equation, if we made a t-chart and we graphed this thing, we would see that if we placed let's say we said x is 4, we can do it 100 times. Every time we placed x equals 4, we would get a y value of 3, because 4 minus 1 is 3. So if we place a specific number for x, we'll always get the same answer for y. So this is a function. It is a function. All right, what about this? Parabola. That's what a curvy line is, like that. Is this a function? Yes, we can use our vertical line test. Go, oh, it only goes through once. No matter where I put my vertical line, it only goes through once. So that is a function. All right, let's look at our XY chart. We're looking for our X values to repeat. Oh, here we have 1 goes with 2, but 1 also goes with 5. So that is not a function because our X values repeat. Number 3, does this represent a function? If I plug in a number for X, will my answer change? If I plug in the same X value, will I get a different Y value? I will not. So that equation is definitely a function for number 3. Number 2, no. Number 3, yes. What about number 4? Look at your X's. They're all different. So it is a function. Look at number 5. Look at our X's. Are our X's all unique? Yes, they are. So this is a function. And this is a function. Oh, the directions say to identify the domain and the range. Hold on, coffee break. Well, remember earlier when I said the domain are all the the X values, and the range are always the Y values, or all the Y values. So if I was to identify the domain for number 4, I would say that the domain are the numbers -2, -1, 0, 4, and 5. And the range values are my Y values, or the output. So I have 0, -2, 3, -1, and -3. All right, what about number 5? Can you list the domain? Pause the video and list the domain and the range. All right, so what are your domains? -3, -2, -1, 0, +2. The range are the y values. So we have 8, 3, 0, -1, and 3. All right, now look at number 6. The first question is this a function? So yes, so 3 goes with -1, 0 goes with 0, -3 goes with 0, which is fine, but none of the x values repeat. So this is a function. We could list the domain. If we did that, we would get 3, 0, -3, -6. And the y values, the output values are -1, 0, and 2. So domain and range, that's alphabetical, right? D becomes before R alphabetically. So does X comes before Y. So X goes with domain and Y goes with range. So that's an easy way to remember that. Number 7, is that a function? Yes, the X's don't repeat. Number 8, is that a function? Nope, because our X's repeat. Number 9, is that a function? Yes, it doesn't matter that all the y values are the same. It doesn't matter. It only matters that there's only one x value listed. Every x value listed is unique. Number 10, what about this blue picture? Is this a function? Would it pass the vertical line test? Yes. It passes it no matter where I make a vertical line. It only passes on that vertical line one time. What about 11? Would it pass the vertical line test? No, it goes through actually 3 different times. So anywhere on the picture, if it goes through more than once. All right, look at number 12. This is actually a vertical line, right? This is the actual graph right there. Well, I could make dots on this whole thing, and if I drew a vertical line on top of that vertical line, it would go through every single point. So this is not a function. This is not. What about 13? Woo, looks like a roller coaster, right? That is a function, yes. It would not go through, a vertical line would not pass through that picture anywhere. So basically, if we wrote out these coordinates, if we wrote out every coordinate, we would only write, every x value we write would be unique. Number 14, is this a function? No, because the x value of 3 goes with 1 and 2. So that's not a function. What about number 15? 1 only goes with D, 2 goes only with B, 3 goes only with C, and 4 goes only with C. So it is, yes, because the x values do not have multiple y values. All right, look at number 16. This, first of all, this is a function. If I drew a vertical line, I wouldn't go through 2 dots on the same vertical line. So this is a function. And then look at the directions. Identify the set of outputs on the graph. So let's say, what does that mean? So let's say we wrote out the coordinates of these 4 points. So what is the coordinate for this one? The first one is -3, 2. -3, 2 is the first dot or point. The second one is -2, -1. Oh, this pen. The third one is 2, -1. And the fourth point or dot is 3, 3, right? Well, if I made this an XY chart, the first row would be my X's and the second row would be my Y's, are my outputs. So what are my outputs? My outputs are 2, -1. I don't have to repeat -1. I could, it wouldn't matter. It wouldn't make it right or wrong. So these are my outputs. In other words, these are the Y values to those 4 points. Okay, does that make sense? Hopefully it does. You'll have a question like that this week on one of your quizzes. All right, so now we're taking, so if you have basically if you have an equation, it represents a function. So I want you guys to pause the video. I want you guys to practice plugging in for X, plugging X into the equations and figuring out the Y values. All right, so what'd you guys get? Did you get 3, 5, woo, That should be a 5. 8, 10, 14, and 17. Hopefully you did. All right, what are the domain? If you had to list those, you'd get -2, 0, 3, 5, 9, and 12. In the domain, you would get 3, 5, 8, 10, 14, and 17. All right, what's next? What about this one? 8 minus 3 is 5, 1, -1, -10, and -9. Hopefully you got those. What would be the domain values? 8, 4, 2, -7, -6. And the range values would be 5, 1, -1, -10, and -9. Example 2, we would have what, 16, and then 8, and then 0, and then -8, and then -12, and then -16. Our domain are -4, -2, 0, 2, 3, and 4. And the range are the y values, 16, 8, 0, -8, -12, -16. Example 3. All right, I'm gonna have to think now. So +3 minus 2 is -5, -5, -8. +9 minus 5 is 4. I don't know what I was about to write. And then we have 6 minus 5 is 1. And then we have -6 minus 5 is -11. Hopefully y'all agree with me. The x's and then the y values. All right, so here is a good question. We have function 1 and function 2. The question is, which of these functions has a greater rate of change? So hopefully you got to go back to last semester. Remember when we found our rate of change is y2 minus y1 over x2 minus x1. All right, so if we do y2 minus y1, we're going to go 80 minus 100. That should be a minus sign. And then y2 minus y1 would be 2 minus 1. So 80 minus 100 is -20 over 1 is -20. So the rate of change for the first one is -20. What is the rate of change for function 2? Well, remember, rate of change is the same term as slope. So the slope of the second one is -18. I'm sorry, I shouldn't have circled the x. -18 is the slope or the rate of change. The rate of change of the first one is -20, which has the greater rate of change. Well, the absolute value of -20 is greater than the absolute value of -18. So function 1 has the greater rate of change. Function 1, because the absolute value of -20 is greater than the absolute value of -18. All right. What about this one? What is the rate of change of a horizontal line? So our last semester we talked about Bucks-Hoy, right? Bucks-Hoy. This means vertical lines have an undefined slope and there's only an x in the equation. That's what Bucks means. Hoy means horizontal lines has a slope of 0 and there's only a y in the equation. Well, this is this is a horizontal line. It's at the y equals 6, so that's the equation, y equals 6. That's the equation of this line. And what is the slope or the rate of change? It's 0. The rate of change is 0. What is the rate of change of function 2? It's the slope, which is 2. So the question is, how much more is the rate of change of function 2 than the rate of change of function 1? How much more means subtract. So the answer is 2. 2 more than. 2 is 2 more than 0. Okay, you'll have these questions this week. I'm trying to help you. All right, that's it, you guys. Okay, so hopefully that helped. Not too much going on this week for functions. Just have to identify them, and then you're going to use some substitution and a few problems. problems. All right. So everybody have a great week. We are going to Zoom when? We're Zooming Thursday at 10. So please, if you have any questions, first of all, you don't have to wait till Thursday. You can always reach out to me. Or if you have a question on a lesson or, just something you want to talk about, make sure you bring that to the Zoom on Thursday. All right, you guys, y'all have a great week, and I will talk to you guys soon.